problem, that better execution plan. So sometimes it's a strategy is just a comparison. Unfortunately, in this example, if you look at the three plans, they look the same to me when I looked at them. But if you can find one that's different, and there are a number of sources, we're going to show you different places we can find plans. If you're on 10G release 1 using the enterprise version of the database and the statistics level has been set to typical by the DBAs on the production database, then we can look at the important SQL from the AWR, and there's a number of other ways we can have a look at them. So our quick solution is check the basics. At any time we do an SQL plan, make sure we got the basics covered out of the box for this particular SQL statement. Then see if we can find a good plan compared to the plan it's using right now. And we'll have different ways of looking at execution plans, being able to interpret them coming up, and then execute the new, better plan. Doesn't matter how we found it from the history in the past or by convincing it to come up with a different plan. So finding a better plan, there are a number of ways. SQL Tune Advisor can help out if you have access to it. With SQL Developer, you now have access to it. In the one in Enterprise Manager, my experience, DBAs, developers generally don't have access to it. Develop a good test case when you're testing your SQL. Testing SQL on 10 or 100 rows always looks great. You need realistic production volumes. Leverage the optimizer by changing some of the settings that influence it that may allow us to find a better plan. And I'm a big fan of using them within a session. Be careful using database-wide. There may be lots of different SQL running for different parts of the application. Fixing one statement with a change in the optimizer parameters may negatively impact a whole group of others. Find a better plan, and then we'll get the optimizer to use that plan in the future, and we'll show you some tools to do that. So the optimizer parameters that influence it. Okay, these are a list of some of them. We're going to look at a more exhaustive list, but these ones are the ones that are sessional modifiable on a particular session, assuming you have alter session privilege. One is the optimizer mode, and we can optimize either for all rows, which is the default, or we can optimize for the first number of rows. And there are actually 3 dimensions, the DBAs, where you can set this to within a particular session. Developers, if they have alter session, can set this within the session. You can do first rows 1, first rows 10, first rows 100, first rows 1,000. There are 4 orders of magnitude. And it adjusts the optimizer's goal around tuning the SQL statements subtly. When you use first rows, it tends to lean more towards index access paths as compared to all rows that quite often they'll lean towards full table scans. You said you wanted to return all the rows. If you're returning a large number of rows, even from a large table, full table scan may be the right access path. Okay. Next up is the optimizer feature enabled. If it had a plan in 10G release 1 that was performing well, or 11G, and you're going to upgrade to 12 and now you don't like the plan it's generating, maybe we put the optimizer mode back to 10G or 11G, get it to generate the plan, confirm it's running, and then maybe we'll look at some techniques to bring it forward in time and use that plan in the future. Okay. But at least these are basic techniques to have a look at other execution plans that are possible. Okay, without having a lot of knowledge of the optimizer. Another one is that for the index, we have a default cost for using it to access data. Okay, there is also a parameter, the optimizer index cost adjustment parameter, that you can change that cost, make it more desirable or less desirable to use an index path by the optimizer. And the last one is optimizer index caching. Once again, around the indexes, is we have a default amount of an index we believe that can be cached in the database buffer cache. Okay, we can increase how much the optimizer believes large indexes can be cached. If they can be cached 100%, it's more desirable to use an index instead of a full table scan than if they can only be cached 10%. It will tend to go towards a full table scan sooner depending on the data volumes than what we're actually working with. So don't forget, having realistic data volumes is also very important. Try dynamic statistics at a high level. It has a default value at a relatively low. For larger tables, it's inappropriate. And dynamic statistics, or dynamic sampling of the statistics, at parse times allows the optimizers to pick the most up-to-date statistics, but it only does a small subset. In reality, it only collects new cardinality information and new selectivity information about the predicates. Another way to try to force a different execution plan is use hints. I think it's great to use hints in this area. You can hint at one aspect and change the execution plan to see the impact. By trying different execution plans with hints, we may be able to find a better performing one. Ways of implementing the new better plan: accept a profile from the Statement of Tune Advisor if it recommends one that has the better plan. Use an SQLT. It's another tool that can be used to collect lots of information about the performance of queries, including the SQL profiles. Or use the SQL plan base. And we're going to have a look at this towards the end of the class and how we can use this tool. Query analysis strategy. We decided that for some reason, and the reason why we might decide not to do a quick tune is A, the quick tuning exercise didn't lead us to a better execution plan that we could find in a reasonable amount of time. If we spend too much time on it, it's no longer a quick solution. Or we just couldn't find a better plan. A better plan wasn't available. We couldn't find it in the AWR, etc. Or an urgent solution is not required. We have the time to go in and look at more details. Or you just desire to find out what the underlying cause was, not a quick solution to get things going again. And you can modify the query. It really requires you to be able to modify, at least for the testing period anyways. This strategy focuses on a more detailed understanding of the optimizer and how it behaves, statistics and parameters for the optimizer around its behavior, and overall understanding of the statistics for the database and both our objects. SQL statement structures and how different structures influence the execution plan, detailed knowledge of data paths, join methods, and how the optimizer makes decisions around join orders, and other operations, just parallel or partition pruning. These we don't look at in great detail in this course. If you're interested in that, we have information available. It's available on the data warehouse classes. Great deal about doing parallel operations and partition pruning and doing partitioning. We also have a 2-day course on partitioning that is also available that focuses on different partitioning techniques and how it influences the optimizer, some of the optimizer techniques, some of the advantages the optimizer can take advantage of partitioning. So we need more data also. We need to collect the current execution plans to decide if a change in execution plan can help out. Information about each table. What columns do we have on the tables? What indexes do we have? And if we're using views with our queries, we need to know the same information for the tables that are used within the views. View is essentially, a regular view is nothing more than a stored query. So it simplifies doing some queries. Object statistics and system statistics need to be up to date. Okay? The optimizer statistics gives us details about your tables and indexes. How many rows are in your table is a very fundamental statistic we collect. And system statistics tells us about CPU resources and how much they're typically used by a workload. The same thing of memory and I/O resources also. We also want to know if there are any histograms on any of the key columns and whether the optimizer is able to take advantage. And what are the parameter settings being used at the time we're parsing this statement. Tools available to collect data. SQLT is an optional tool that will collect very detailed information from about particular SQL statements. We have documentation on my Oracle support about this tool and how the DBAs can install it. Usually it's considered a DBA tool. But once again, as a developer, you can ask the DBAs on the production system to provide some of this information to you. DBMS stats will allow you to get some details about the stats and should be used to keep it up to date. If they're not using the automatic job we have introduced in 10G release 1 and continues on in 12C. And we can turn on extended SQL tracing to get additional information that can be useful while doing a tuning exercise on the database. And TK-Prof will give us very good information about individual statements. There are also a couple of reports that can dump out. One is from, if you don't have the Enterprise Edition, you're using a standard edition of the database, you don't have the AWR repository available and the snapshots we take, there is an older statistics snapshotting package that can be used, and it has a report that will show you the most expensive SQL and the resources they're taking to execute them and the details around it. And if you do have the AWR available, it's turned on and collecting data, there's an equivalent report from the AWR data that gives you the similar information. The details around a particular SQL statement or a group of statements. And we found there are a number of common mistakes that are made during a tuning exercise. One is we're doing testing on unrealistic volumes of data. The production has 100 million rows in a table. The test system has 1,000 rows. 1,000 rows does not a realistic estimate of the 100. Doesn't give you a realistic view of what the production server is doing. Best is a test system with identical volumes. Okay. Ensure that no join predicates are missing. It will do, if a key equal join predicate is missing, it will do a Cartesian cross product. Most of the time, Cartesian cross products don't answer useful questions in real applications. So be very leery if you see a Cartesian cross product. Even if it's just a filter, we may miss an opportunity to reduce the data. The application should only return the rows and the columns they need at a particular point in the application. Be careful, try not to write generic SQL that's used in too many areas of the application. That leads to returning more data than the application typically needs at any one point. Look for unusual predicates. If they don't make sense to you, they may not answer a typical business question. Be careful for constructs that are known to cause problems. Large in-list or OR expressions. We can use multiple indexes if we're ANDing equality conditions together. If we OR them, we can't. Watch out for outer joins. It limits the optimizer decisions. Sometimes an outer join can be restated as a regular join that some people call inner joins. And hierarchical queries are very expensive to implement. Okay. Be careful with views. The views work very well. It's just that sometimes Trevor gets carried away in their use. And I write them too deep a structures. And then I'm joining lots of tables, and then I write a query on a deeply netted view where I'm only using a small subset of the data. Then we're potentially doing lots of extra joins we don't need to do. And watch inline views and watch subqueries. They can also cause problems. So, analyze an execution plan. This is an overview. We're going to look at more details as we get into the details of analyzing. Examine the access paths, full table scans versus index scans and fast full scans. An equality lookup on a unique index for one value is a really fast operation. If we're looking for 1 out of a million rows, that's the fastest way to get it if it's a unique column. Okay. Examine the join orders. Generally, we like to join the smaller tables first. Outer joins changes that because the outer join has to be done in a particular order or you don't get the right answer. And sometimes correctness overrides performance. It's good to go fast, but you only go fast if you can provide the correct answer into the query. Okay. Watch the type of joins. Okay, we do 3 fundamental type of joins that the optimizer typically uses: a nested loop join, a hash join, a sort merge join. They have different advantages in different cases, particularly for different data volumes. If you want the first few rows the quickest, a nested loop with an index, at least one index, is the fastest way to get the first couple of rows from a join condition. If you want to join a large volume of data from 2 tables, and you're going to use most of the data, perhaps a hash join is more efficient. And we'll look at the details of these later in the chapter on the optimizer and how it does joins. Okay. Review the actual number of rows returned by the statement versus the estimates that the optimizer used to decide on the execution plan. Estimates are estimates. We don't expect them to be exact, but they should be close. If they're more in an order of magnitude difference, then I have a concern. You know, if I estimate on 5 rows and I get 7, I'm not worried about it. If I estimate on 5 and get 1,000 back, I got a problem with how we're estimating the statistics for that table. We either got invalid statistics or we miscalculated the selectivity of a predicate. Okay. Okay, also look at where there's a large discrepancy between the actual and the estimate number of rows. So that could indicate a problem with the rows being returned. Look for the plan step where the cost is a lot different from the logical reads. We looked at other factors outside of logical reads, but logical reads is the single biggest factor. They should be fairly close in reality. There are umpteen ways to go after the execution plan in the database. Earlier than 9.2, there were only a couple of really simple that still exist: auto trace and explain. TK-prof, autoplace, and the explain plan. Okay. Today there are many ways that you can get it around. You can get it by looking at the $V views. $SQL plan shows you what's in memory right now being used to execute statements. $SQL plan monitor is used for monitoring long-running statements. It includes the execution plan. We can dump them from the AWR using a DBA view. Unfortunately, there are no user or all views version of this. Sorry. So you may have to have the DBAs provide this information on a production system if you don't have privilege to access that views. You can get them from the management base if you have the privileges, the SQL tuning sets, the turning on tracing with DBMS monitoring. You can also, the DBAs can set event 1053 to collect the detailed tracing. You can also still set it with alter session SQL underscore trace enable. It gives you the same thing as these do too. You can get them the execution plans from the TK plan report, what we call lovingly SQLT. The SQL traces contain them. The extended traces have them, and you can format them a little nicer with TK Prof. And the two reports that we mentioned earlier on. Review the common observations. Watch out for the way you write the SQL. In lesson 4, we're going to talk about some known issues. We're going to talk about when indexes should be used and not used and why they're useful. Okay. Index cannot be used if it doesn't exist. The optimizer can't use it as an access. Watch we're not missing an index for one or more predicates on the query. Watch the optimizer hasn't chose an inappropriate join order for some reason, because quite often bad cost information. It doesn't have up-to-date statistics. Watch for the join types. Predicates are not pushed, views are not merged. And the optimizer looks at a number of transforms. We certainly don't look at all of them, but on the chapter under the optimizer overview, we'll look at some of the transforms it looks at. Sometimes it costs the transforms due to inappropriate costing information. It doesn't use them because of the cost looks too expensive. And other problems, we only listed a few of them. So if we have one of these problems, how do we fix it? Well, bad statistics, gather more up to date. Have the DBAs do that on the production system, or you can gather it sometimes yourself on your own test system. Create a new index or recreate an existing index if we don't have an index for this query, and one will give us a better execution plan. Use the Access Advisor with the tuning pack if we have access to it. Use the hints to get a better plan, to find the better plan initially. Use SQL plan management to have it use it into the future without having the hints on it. That's one of the real advantages of the SQL plan management. Use dynamic statistics to get better selectivity and cardinality estimates at runtime. Eliminate data type conversions. If you don't have to convert the data, don't. If you do, control your destinies. Create a function-based index. It will open up the opportunity, if we always use a function with a column, to use an index, where if we hide it with a function, normally it can't use it. And rewrite the queries to permit the use of existing indexes. And when lesson 4, we look at a lot of examples from different areas in here. Finally, we're going to have a quick look at the development environment, and we're going to see this in some detail when we do the practice a little later on. Okay. We have two environments. We're going to show you the SQL developer and SQL planning, and I do a more extensive overview of these as we do the practices. SQL Developer is a free graphical tool that improves productivity and simplifies database development tasks. It's available to be used against the Oracle database. As long as they have a JDBC connection string, it will actually work on other databases also. You can connect to any target database schema by using standard Oracle database authentication, username, password. It also knows advanced authentication techniques, but we keep it simple in the classroom and just use username, password. And you get to experience it in the class. If you've already used it, you'll find practice 2, which is our first physical practice to do in the course, very easy. If you haven't used it, you can have a look at Appendix A that gives you a little more information. And on the Oracle Learning Library, out on OTN, there is also some examples on using SQL Developer. They have some things that are new with it and how to use it. We can also use the traditional SQL Plus to write either SQL or PLSQL, Procedural Language SQL. And this was just a little example. To run SQL Plus, we need to set up the environment variables at the terminal session level. It's a little command line tool. So we call dot space, and the space is critical, Aura ENV. And it will ask us for the Oracle SID, the system ID for the database. In our case, we're using Systune. It will set up the Oracle home, the Oracle base, the path, etc. for us. Then we can fire up SQL Plus, log in with an account. They're using SQLT, which is one we use for the demos. It has a magic password. Because they didn't give the password in the prompt, they have to type it in, but then it doesn't echo it, so it gives us a little bit better security. You can also put the username password on the prompt, but be careful on Linux systems. If the sysadmin hasn't taken proactive protection on the Linux system, people can see your username passwords. In our environment, I don't worry about it. We tell you all the passwords anyways. In a production system, I would be careful. And then what they're doing is setting server on and writing a PLSQL anonymous block to do hello class or hello world. Everybody likes those because they do them in C and in shell scripts. So this does the same thing. It's just a little example of the code.